All right, it's Mr. Rops.
Hi, Mr. Cole.
Right, and we are going to do an example of some linear regression. And step one says to make a scatter plot. Well, we take our points here and we start putting it on. So I go 2, 1.
No, so that table's just a set of coordinates, basically.
Exactly.
3, 0, -1, 3, and 0, 2.
And then 5,
and 5, -4. They look like they're going in a line.
Right, so now it says describe the set of data. Well, the direction, what would you say for the direction?
It's definitely going down, so it'd be negative.
Negative. And then the strength?
Yeah, it looks quite strong to me. I'd say strong or moderate.
Okay.
Strong? I think strong.
Trend. Would you say there's a linear trend there?
Yep, that looks like a straight line.
Linear. And then any outliers away from the general trend?
Nope, they all look like they're going pretty close to that line of best fit if we were to draw one in.
All right, so now we're going to put a line of best fit on here as best we can. I think a line of best fit will go something like this. And I will wiggle it around a little bit. And so...
Yeah, that looks pretty good. You want about the same amount of points above and below, don't you?
Yeah. And so if I want to now make my own line of best fit, I'm going to choose 2 points which kind of represent it. And that point, I'm going to choose this point here, which I'll estimate is 0, 4. You okay with that?
Yeah.
And then maybe this point here, which looks to be about 2.5, 0.
Okay.
Okay? And so those are reasonable points on the line. Are those the only 2 points I could choose? No, I could choose maybe this point. Here's a nice one I could have chosen.
Yeah, 8, -5 would have been quite a nice one as well down there.
Down here?
No.
8, -5 here. I even like that one. 8, -5. And this one was a nice one too, -2, 5. Let's maybe use those 2 points that are out
nice whole numbers, yeah, they're good ones.
Out on the ends. All right, so we need to find our slope. To find our slope, well, we can count the slope or we can calculate with the formula.
Okay.
I'm going to do the formula. y1 minus y2.
Okay, so that's going to tell us the rise.
Okay, so do you tell me the values there, Mr. Cole?
So we've got 5, take away -5. Okay, and so that tells us that the rise is 10, basically.
10.
And then the run is going to be x1, so -2, take away 8.
Which is -10, which is -1. Well, not convenient. We have a slope of -1. Now, we need a point, our x1, y1. We can choose any of those points.
Yeah.
Which would you like to choose?
8, -5.
Okay. And then we go to y minus y1 equals m, x minus x1.
Okay.
And so we get y
minus
a -5.
-5, so add 5, yep, equals -1, lots of x minus 8.
And so we get y plus 5 equals -x plus 8.
Yep, and then add x to both sides.
Oh,
sorry, what are we doing?
I'm going to put y equals mx plus 5.
Oh, right, sorry.
It didn't specify, but I'm already halfway there. Subtract 5 and I get plus 3. And so there is my equation of the line of best fit.
Okay, good.
Okay, so now we need to do it with our GDC.
See how close we got.
Exactly.
So your GDC's got a way of doing it more accurately.
So we're going to do it now. D part says to use our GDC to find the regression line. And so with this GDC, when you're watching this, make sure you have your calculator ready to go and you're following along with us. It means you're going to be pausing it a lot to make sure you can do it on your calculator itself.
You might need to pause and go and get your calculator.
Right. So wait, we'll wait for you. Oh, we're back now. Because you just paused it. All right, so first step, and to do this, I'm going to turn on my keystroke so you can see what I'm doing. I'm going to go to Stat, and I'm going to Edit. And I'm going to put in L1 and L2. X is going to be my L1, so I'm going to go 2,
3, -1, 0, and 5. Okay, and then list 2 is going to be y, so we've got 1, 0, 3, 2, and negative 4.
2 and negative 4. Okay, great. Let's clear the history so you can see what I do next. Okay, so now what I'm going to do at this point is I'm going to go to my second y equals, which is my stat plot. And I'm going to turn on number 1 by hitting enter. And I'm going to take these ones that are bold. I like plot 1. I'm going to turn this on. And then I have different types. If I toggle over, I can see the different types. But the one I want is this first one here. So I'm going to leave it as is.
Yep.
My x value is L1. My y value is L2. So those are all good. And then I'm going to go to zoom. Oh. Then I'm going to go to zoom.
Okay, you've got zoom stat.
Right. Somewhere along the line. Oh.
Nope.
Where's number 9? Zoom number 9. Oh, I had it there.
9.
Click 9. Zoom 9.
Yep.
And it will make a special window that fits exactly. And this looks very similar to my blue dots here. That's a good thing. Okay, so now the next step is I'm going to go. I clear my history. You can watch these steps. I'm going to go stat, and then I'm going to go to the calculate menu, and I want to do linear regression, number 4. 1, 2, 4. Okay, and I have to tell the calculator what I'm going to do. I'm going to do second L1, which is number 1.
So that's your x's.
My x's. Second 2, which is L2, comma. And then I'm going to put it into y1. And a shortcut to get my y variables, I can go alpha trace, and I'm going to put it into y1.
Okay. The other way of doing it, if you've got the other system, is you can go variables, y variables, function, y1. So it's a little bit longer.
Right. So then you get y1. Okay. So at this point, I hit enter. And it takes this equation here, and it puts it into y1. And if I hit graph, you see that it fits there. And there's our linear regression. So if I, let's call back my computation. So if I pull this over here now.
No, we don't need all of those significant figures. We can only just put it to 3 significant figures. So
that's a good rule of thumb, isn't it? 3 significant figures. Okay, so if I make this a little bit bigger, I can see it. And so if I make the equation, I get y equals negative 1.079, I guess that's 4 significant figures, x plus my y-intercept is 2.34. If I look at the calculator's linear regression, and I look at my linear regression, they should be reasonably similar. Well, negative 1.079 is very close to negative 1. 2.34 is reasonably close to 3. So I think we did a pretty good job. Would you say one is better than the other?
Yeah, I'd say the calculator one, they've used some maths to make it a bit better. Right. But we don't really need all the significant figures. We don't need to make it better by having 10 significant figures. I think what we've got is good. We could actually look at why don't we put y2? Why don't we put the one that we did and see how close we were?
Ah, good idea. Okay, so if I go back here now, I'm going to go y2. I get negative x plus 3.
Let's see how close we were. So that's the one that we did. We were a little bit high. You can see that on the graph that our one was a bit
higher than
it should be.
Right. All right. Fabulous.